So in this video we are going to talk about the remove method. Alright, so we made add after, add before methods in our previous video, and so let's begin our code for the remove method. Okay, so this method is going to look for an item, look for the node which contains the target data, and this method is going to delete that node. Okay, so first we check uh, check for empty list. So the statement will be if self dot size equals 0 and not self dot head and not self dot tail. We are going to print no data. Elif, before elif, let's write the comment. If the list size is 1, means list contains only one node and we have to delete this node. Okay, so if self dot size equals to 1, so now first let's get rid of the dot next and dot previous attributes. So self dot tail dot next is set to none again. Now self dot head dot prev is set to none, and now self dot tail equals to none, and self dot head will be a none again. So everything is set to none, means none of the attributes are referring to the new node variable. Okay, so finally self dot size is decremented by 1. Okay, we have to keep tracking our list size. Now the third condition is if the list size is greater than 1. So elif self dot size is greater than 1. Now what we have to do is we have to make current node variable, and it is set to self dot head. We are again starting from the head node. Now we have to create previous node variable and it is set to none. So while current node, so I have explained in my previous videos why I am writing while current node. Okay, so let me write it. While the current node is not a none. So this is the meaning of this statement. So while true, okay, so while the current node is true, it means while the current node contains a particular node and not a none. Okay, so if current node dot data equals to the data which we have provided or which the user is going to provide to this function or this method. So then pass for now, else previous node equals to current node. So we are storing the current value, current reference point of the current node to the previous node, and we are updating the current node to current node dot next. So we are hopping to the next node like this. Okay. So now we have to check different conditions now. So our first condition is going to be removing the head node. Okay. So now we are going to write the code to remove the head node or delete the head node. So to find the head node, we are going to create our if statement. So if current node dot prev equals to double equal self dot tail. So if the previous node of the current node is the tail node, it means that we have arrived at the, so the node is the head node. So we have arrived to the head node. So now we have to do something like this. So the so we have to create a new variable, and it is going to be called the next node, and it is going to store the value of current node dot next. Okay, we will be needing this variable later. So now what we have to do is we have to delete, or we have to just nullify some values. So current node dot prev equals to a none, current node dot next equals to a none again. Then we are going to delete the current node itself, and now the next node dot prev equals to self dot tail. Okay. And self dot tail dot next equals to the next node. So we have interconnected the next node variable to the tail node. So we have deleted the current node, and now the self dot head will point towards the next node. So let me add this comment that next node is the new head node of the list. Alright. So now we have to check for the condition removing the tail node. Okay, so this time we are going to remove tail node. So if current node dot next equals to self dot head. So if the next node to the current node is a head node, it means the node is the tail node. So we have arrived to the tail node, which we have to remove. Okay. So as we have already created the previous node variable just before starting the while loop, so we are going to be using that variable, right? So let's nullify some values again. So current node dot prev equals to a none, current node dot next equals to a none, and we are going to delete the current node. Now we have to interconnect the previous node to the head node. So previous node dot next equals to self dot head, and self dot head dot prev equals to the previous node, and this time self dot tail is going to point towards the previous node, because we have removed the tail node, and the previous to the tail node was this previous node, right? We have already been tracking the storing the reference of the previous node in this section. So the previous node, let me write this, previous node is the new tail node. Okay, of the list. Okay. And now we have to check for the last condition of this method. So removing any random node but not the head and the tail node. Okay, so else, so we are going to create again the next node variable, and we are going to store next current node dot next. We don't need to create the previous node variable because we have already created the previous node. So now this time what we have to do is we have to delete the current node and we have to interconnect the next node to the previous node. Okay, so current node dot prev is again set to none, current node dot next is set to none, and we have to delete the current node. And now let's interconnect the next node and the previous node. So previous node dot next is next node dot previous equals to the previous node. All right, and so yeah, we are done, and now we have to decrement the size variable by 1. So we are decreasing it by 1, and again we have to return something. So just to avoid infinite loop. Okay, so I think we are done, and we just have to check the values. So let's just run our code before removing the values, and let's just decide what we have to remove. So we have to check all the three conditions at once. So we are going to remove -3 the head node, we are going to remove 4 the tail node, and we are going to remove 0. So -3, 4 and 0, right? So my list dot remove -3, my list dot remove 0, and my list dot remove 4. So let's see how it goes. Oh yes, it works. So -3 has been removed, 0 has been removed, and 4 has been removed. Okay, so backward is also working fine. 1 2 3 4 5 6 7. Okay, so yes, our code works fine. So this was our remove method for circular doubly linked list. Okay, so Thanks for watching this video, and we are going to cover some more methods in the next video. See you there.